My name is Ram Dantu. As you can see here, we are from University of North Texas. I'm a professor there, and they're all of my students, PhD students. One of them is actually here, and we're going to present today about can an average Joe secure our network. Before that, just let me introduce myself. Half my life I spent in the industry. So I worked for Cisco Systems, Alcatel, Lucent, Fujitsu, and for the last 15 years, I've been working with UNT. I'm a professor there. I'm also a visiting professor in MIT. So we are actually trying to develop something that a lot of people here in this conference have been talking about for the last 2 days. One thing is that how can you share the information from all the citizens and secure the cyber? That's the key. So actual information is with a lot of people, not just the system admins. That's the hypothesis in this particular presentation. What it means is that you go to a motel, who knows a lot of information that's actually happening in the motel? Probably it's the janitors and the cleaners and the front desk. Those are the people, they understand what's happening. There are drugs or something else, right? Same thing with Starbucks and other places. So we want to actually understand how they can give commands, and that can be transferred into network rules or actual network security, cyber security. That's the thing which we are trying to attempt. So what we did is we went and actually surveyed around 1,000 different people, various people, kind of in the pharmacy, people sitting at the front desk, or in the clinics, or in the motels, or in the Starbucks, or other places. And by asking them, hey, can you tell me if you want to say something about cybersecurity? You want to, let's say, I want to stop Facebook for my son from night 10 o'clock afterwards. So that's all simple language. Then how that language can be converted into actual rules or network security rules. So the English-like language has to be actually the input so that we can actually involve all the citizens. That's the hypothesis for this average Joe securing the network. So with this, let me start going with it. So we have actually built a natural language processing engine that will enable the technology. Anybody, average individuals, they don't need to have any technical background, and they should just speak English. We are also attempting now in the future work to actually input from voice commands. So they can actually do the voice commands. Meaningfully, that's important, meaningfully secure the network. That's the key here. So I'm sure now we can understand now the impact of this for IoT. Once the large number of devices comes into the picture, into various places, that's where the people will be actually interacting with. And people who don't understand the network should be able to control the network and configure. So I'm actually going to talk about problem definition survey. We actually did the survey of all the average Joes, in the sense we went and actually collected information from them. And we are also going to talk about the background and kind of implementation, how we did it, and we actually used OpenStack in the private cloud, and we actually implemented it, and we got results from that, actually. That's what we want to present it to you. So just incidentally, I actually, there is one congressman from our city where I live in Dallas. He actually threw a challenge to all the people. Surprisingly, I was there in the audience, and he said, I want citizens to come in and secure our network and have cyber. I want to throw a challenge to you. If you have got ideas, come back into me. And then I didn't know that, that he was actually thinking about this. So I went to him and said, hey, we have some idea like this. Then surprisingly, he immediately pulled my badge. And he said, called his staff and said, hey, can you take a picture of this badge? And I want to talk to him later. So that kind of interest is when the government people have got how to involve the citizens. Especially in October of every year, we have a Citizens Awareness Month for cybersecurity. I'm sure all of you know. And that's where this kind of activity will fit in, and they can actually help us to secure the network. So we are going to actually show you some test results and some performance results. And the methodologies, again, I was talking to you, we want to actually, if they could address certain kinds of network-related problems, best way is first to give participants a survey. We just want to understand how they can actually, because before we build the NLP, the natural language process, we want to understand how the people talk in English and how we can actually have the grammar, we have the semantics and syntax, all those things together, we can convert them to that. So I want to show you some of the survey results first before I go to the technical details. Again, we're actually, that's the interesting thing is that can they actually create security configurations? Can they using English? And not just talking that can be converted into. And of course, the same non-professional. Interestingly, what is happening is that there is an organization called IETF. I'm sure, how many people have know IETF? Oh, interesting. Internet Engineering Task Force. That is the one that actually defines all future protocols of internet. And if you say, starting with old TCP, to anything new, SNMP, whatever you call today, what you use in everyday life, in cyber, that's all defined by IETF. There are a set of several thousands of companies come together once in 3 months. They define these kind of protocols, network protocols, which will be actually used in everyday's life, what we are using right now. So they actually created a form called I2NSF, Network Security Functions, how they can be generalized. That's what they have a working group, they have actually generalized. So that's how we started the work. We started, okay, can we use this IETF work and generalize across Cisco, across Juniper, across Palo Alto, whatever devices? Can we generalize this? This is called I2NSF. That's what IETF calls it. So that's how we started work, but slowly we got distracted to how we can actually input from the users. So this is the first question we asked. So we asked the people, hey, you have your house or your business, how do you want to handle any objectionable content? That's what I asked them. As you can see here, most of them said, you know, hey, I want to block anybody in the workplace actually using any pornographic material or something else. And whatever is safe in the workplace, that's what they want to allow. That's, if you see here across, the highest people, they said, of course, you block the sexual content, but everything, terror and other things, also they come into the picture. Gambling, intellectual property, of course, and social media. Social media is a big thing. You know, there are a lot of companies, they want to actually block it. So these are all things that actually a normal average Joe can talk and say, this is what I want to block, for example. So the next one we asked is that how actually there are people in Starbucks. We went to ask Starbucks people. I know there are people who don't buy coffee from you. How do you want to use? Can they use your the Wi-Fi? They said no. We would like to actually use put some username and password for people. That's what a lot of businesses said. That's what their survey we got it. Some people said no problem. Anybody can use, come sit down and use it here. The next question is that network bandwidth. So if a lot of people, I'm actually not going to talk about net neutrality, of course, here, but we asked those people, Starbucks and other motel and other people, whether what happens if the people come in here and they start watching videos on network bandwidth. A lot of almost everyone said, I think 50% almost would say, throttle. Throttle the for time, they can only use the video for certain time or certain volume. So again, these are all the commands they actually gave us in writing. Okay, so we are actually using this, what they gave us in writing, from NLP to some standardized rules, from standardized rules to various kinds of network security function devices like Cisco, Juniper firewalls, IDS, IPS, and other devices. That's the whole thing. I just want to give you information why we are doing this kind of thing. Because we want to understand how they actually use this information. The next one is that Skype and VoIP calls. As you know, most of your 5G networks, they use 4G networks, they use voice over IP. That's what all of you use 4G, so all of you use voice over IP networks. So how do you want to handle this spam calls? So they will say in simple terms, this is what I want to do, like block the calls, or completely disable the Skype. I don't, there are people start calling me from Skype, so I want to disable it. So, or send it to the voicemail. Some of them are useless responses. The next one is somebody actually trying to get into your home network. What do you want to do? Obviously, increase the security strength, change credentials, or use IDS and IPS. So this is another thing which people would like to do when you ask them. Again, when we ask them about remote access, somebody is trying to access your computer, what do you want to do? Of course, remote access logins, you actually disable remote access logins. Yeah, this is an interesting thing which we have asked them. So, for example, when you are not at home, when you are on vacation, and somebody is near your door, near your garage door or something, normally what you do is you ask your neighbors, hey, can you keep a watch on it? Okay, so existing new IoT device, other things, is it possible that we can actually use motion sensors to actually alert my neighbor? That's what it is. So they can actually give commands of this, and the email or something will be sent to the neighbor. So that is a question which we asked. These kind of commands and rules will be actually downloaded into their routers, wireless routers. That's one another practice what we want to do. This is more related to electricity use. What we have in mind was cryptocurrency mining. A lot of people are using. What do you do when you find out that large amount of electricity is being used? This question did not go well because a lot of people did not understand about mining, cryptocurrency. So that's what this question is. However, this has a real application to IoT, Internet of Things. That's where we actually can understand how the electricity is being used across all the devices inside the house. Across as you see here, the age is anywhere from 20 to 60, even I think 70, 79 people are there, age people are there. So this is the overall 29, 30, 39, these are the people. Again, we went and asked the people who have no knowledge of computers and computer configuration kind of people. Job categories, various kinds of people working in clinics, service industry, maybe unemployed, maybe blue-collar workers, students, and some of them are white-collar workers. So those are the kind of people which we have asked these questions. Again, gender, we have almost equally to male to female. We have equal male to female. So this is the kind of background which we started with. If you've got any questions, you can stop and ask. If I know, I'll answer the questions. If I can't, one of my students is here. If he can't, well, some more people, I will give their email address. So so I'm actually going more into technical details. So as a university, we thought first of using a public cloud. We started with Amazon. And what happened was we started running out of money, basically. Charging us a lot of money. So we said, we got to use something else. So that's where we have cost is came into the really big picture for us. Then we actually stopped it, and then we started using something called OpenStack. How many people are familiar with OpenStack? Okay, not many hands. Okay, three, four hands. Okay, so the OpenStack, you can nicely build private clouds. All the enterprises are using right now. I think it's very, very important. So a lot of people, most of the young people should learn this because almost every enterprise would like to use this kind of OpenStack for their cloud infrastructure. So this is very compatible and flexible with many hypervisors, and the most important thing is it is open source. So we can actually take it and change wherever we want, and we can actually deploy it. That's what we did. There is a controller node there. There's a compute node there. As you see, controller node, basically is management of software, all the services, how we actually download it into the compute node, mostly virtual machines. Network node in OpenStack that takes care of all the network connections between virtual machines inside the cloud. And then we have a storage where we actually store the information, data. It can have disk images or any libraries or even persistent storage here. So this is typical network security functions. I'm sure everybody of you know this diagram. This is typical 30-year-old or 25-year-old standard stuff. So this is what I was talking about I2NSF. This is the working group that is created recently by IETF to how we define all these firewall rules and network security functions across all the vendors. So that's the key for this group, which they actually created this group. So we took the average Joe's commands or requests, converted into I2NSF commands. Those will be converted into the Cisco Juniper firewall actual rules, and we tested them. How good they are. When you download them, sometimes Cisco or Juniper devices reject them. Then once it is rejected, we pull it back, send it back to the user and say, hey, the system did not understand what you said. Can you please rewrite it or redo it or just speak again, say it again? Then they say it again, then we reword and put the different grammar or rechange, and again we download it. I'm going to show you some results, how well we were able to do it. And this is only first step. And of course, there's a lot more to be done, especially when it comes to the IoT. These are very standard stuff which we have used, NetFilter, Cisco stuff. Recently, we received Juniper one. We will be actually downloading or implementing in the Juniper as well. So that's the kind of devices which we have used in this experiment. Then I'm going to show you the design and experiment. So this is a very important diagram where you can see here in this one, there is interface 1, there is interface 2. I can't, the laser pointers are not coming up here. Okay. The interface 1 goes to the controller node, and my system is nothing but my Joe system, average Joe system. That's what it is. And we, of course, we create the message queues. And the bottom one is where we have hypervisors and VM1, VM2, you know, those kind of compute nodes and network nodes, they are there. So that is the kind of basic infrastructure which we plugged in our system into the OpenStack. The top interface, that's where we're actually going to do access controller, where you input all the policies coming from the web page. What it means is that initially what we did is we created a web portal where people can actually write their commands, they write their English-like commands, and then that's how they inputted it. And that's how what means from the web page. And as you see here, is a web page, so anybody can, from anywhere, can actually enter these commands for their enterprise or for their home or whatever it is actually. So this sequence of the interface can actually access. Also, there is an update on the blocked content file. There will be a file which will be accessed with some blocked content, what kind of content you want to block, then also IP list where we want to reject. Those kind of things are already there in the interface, which will be downloaded into interface 2 from interface 1 to interface 2. So as you can see here, interface 1, we have a login form, and we have different rules from there will be created, and in the general policy engine. So access control, the fields display. This is more technical things. As we can see here, the user role depends on fields, or depends on the user role. But again, this is all hidden from the real user. Okay, so the average Joe has no idea what's going on in the back end behind. So all he knows is he speaks through a microphone, whatever he wants to say. Hey, I'm walking through this thing, it looks like very hot here. Or I'm walking through here, there is something else going on here. So there are a lot of issues when you want to convert these things, because there may be duplicate commands. There will be commands that cannot be understood. There will be some commands which will be overlapping. There will be, so many issues are there when you are actually implementing real life language, when you want to convert it into. So what we do is, first we do the grammatic check engine, then of course we have a translate engine, we have semantics, and of course we discard some policies if they don't fit in, or we go back and ask you to feedback to the user. Okay, so that's what is happening here. So grammar check engine, basically it will take from whatever is the input is given, it will check the grammar and then translate it into a IETF based policies. From IETF based policies, they will be converted into Cisco or Juniper Firewall specific policies. The phases of this one are interpret, translate, and install. We will interpret, part of it, we'll check the grammar, semantics, and validate it. Semantics is the one that what it means is that whether we understood the meaning of the sentence. Okay, so the grammar is whether the sentence means valid or not. Obviously, we are going to detect keywords for the firewall, whether I have to download it to the firewall, IDS, IPS, or something else. That's what I understand. It's another challenge, right? Because the user can say, do this, block the PC for my son from night 11 p.m. That's all he's going to say. So we have to understand what is your son's PC, right? And what is the Facebook? Well, so those are the things that have to be understood. This is another challenge which you have. And after translating, challenges are you have to construct an NSF rule, network security function. That's what I was talking to you about, IETF working group rules. So why I'm talking about IETF is that the existing vendors are very serious in moving to those kind of rules. Okay, that's the reason why. Okay, there are standard rules. So mind you that when you want to share information, even the vendor to vendor, you need to have a standard base set rules, right? So from the client to the router to the whatever is server, we need to have standard rules. That's the only way they can share. Okay, so that's where IETF working group is coming into the picture. Then, of course, you transfer the output file, execute them NSFs with new rules. That means I showed you before the diagram, interface 1, interface 2, the bottom one will be downloaded. So the user is only accessing the top one. So it is simple grammar. You can see here, alert, log, activate, allow, accept, permit, deny. These are all simple actions. So when, what kind of protocols, from, where. So it's a simple firewall rule. You have to somehow grab it from a person who is talking. That's the challenge from natural language processing. So you can see here the example, alert when ping from PC1 to PC2. Okay. So we have to understand all these words and convert them. For example, look at here, the top two ones, the blue ones are okay, the bottom one is not okay, because it didn't understand the sequence how it was put it in. So it got rejected, most likely it got rejected, and it will be sent back to the user if it is required, and the user has to retype it or say it again. Again, it's more technical stuff, what it is, but that's not, we don't need that information. The IDS rules, the IDS rules will tell what kind of URL, is it a protocol FTP, is it a TCP, or you can resolve the host name to the IP address. Did you detect the protocol? So those are the kind of things which were. So again, it's not example. We generated the alert system with this is SIP call from project PC to my network. So there is a call, SIP call is coming. SIP, this is a protocol used for voice or IP. So we have to understand that somebody wants to block a voice or IP call, and then we understand the SIP protocol is being used. Again, there's a block so-and-so web page to host A. So as now we can see why I'm talking this one. This has clear relation to the initial survey, what I've shown it to you. In the survey, we asked a lot of questions. Those questions, those words, whatever they presented, will be converted into this kind of rules. So we can see here, allow internet traffic to somebody's PC or somebody's laptop. Those are already converted into the access roles into the Cisco firewall. So again, another example of this block all websites to my network from 9 a.m. to 4 p.m. So this is particular command that has got converted into the Cisco firewall rules. So then what we said is let's go and test the performance. So there was 1,000 inputs are there. And this was used by one of my students who did his thesis in this. So he actually got these 1,000 inputs. There are several various kinds of people involved in these inputs. And so we have different kinds of performance analysis. We call accuracy, precision, recall, and F1 score. These are all the typical performance parameters that we use for natural language processing. When you are trying to convert English-like language to the machine understandable, machine learning kind of language, and these are different standards or metrics we use to convert, to actually test the performance. There's also, we actually see how well we match, how good we are, our NLP machine is, means there are two mathematical formulas, Levenshtein distance and cosine similarity, that are used to figure out the similarity of what we generated as what Cisco is expecting, for example. Okay, so that's what those two performance parameters are. So at the end, we install the accepts or reject. So there's nothing in between. If once you reject, you go back and redo it. Just for information, the semantics is the branch of language. So basically, what is the meaning of that? The words and sentences. You got to understand. So machine learning is the one normally to understand what's going on there. Syntax is basically grammar rules. You know, you want to put subject, object, verb, and all those kind of things. Those are the things we have to understand. Grammatical rules of a language, kind of syntax and semantics are part of the grammar. I just want to set the definition. So we can do that. So the precision is the total number of interpreted policies versus all the number of all interpreted policies total. The second one is how many are correct, correctly interpreted, supposed to be correctly interpreted. This is recall. So as you can see here, our percentage of recall or precision or for the grammar is probably around 89% to what goes up and down kind of thing. But when it comes to the semantics of it, because we are not able to really understand everything well, as you can see, it's kind of going back and forth, so that's where we need a little bit more improvement there. So it's only around 0.76. Okay, so from the machine learning point of view, 76% is pretty good actually. When you look into all the papers kind of thing. Okay. Again, they calculate any of these conversions into something called F1 scores. The F1 scores are basically 2 multiplied by precision multiplied by recall divided by P plus R. That's what the formula is. So I'm not going to go much into the formulas, but overall the total accuracy is 90.7%. So we have, this is weighted accuracy. F1 scores are also almost like 0.7, 0.8 kind of things. For people, F1 scores are, this is an interesting chart. As you see here, the blue one is minimum knowledge. People who have minimum knowledge or moderate knowledge or good knowledge. So even people with minimum knowledge are able to get almost like 0.7. So we're able to translate, because they were able to tell whatever they want to tell. But whereas people who have good knowledge, they can tell you more accurately what they want to say. That is, good knowledge means people who have got computer knowledge, firewall knowledge, and those kind of things. Now, string similarity, how well we match to the Cisco firewalls, SNOT, IDS, or the simple IP tables in the servers. So you can see here, it's pretty much like 78 to 80% or even more than that, based on what kind of vendor we are actually trying to use. Again, these are similarity, how we actually have considered with the different distances. Levenstein distance or cosine distance, they're very close. That's what we want to prove. This chart proves that either one will work kind of thing. But again, the lower, that 55% is not good, so that needs to be improved if similarity is there. The acceptance rates and rejection rates by the network security functions across all the three you see here machines, 85%, rejected 14%. And again, if I add my rejected ones going back and coming back, going to the user and he read us or resay, and then it will be, this whole percentage will increase again. So that's what is going to happen. Oh yeah, this is important for the IoT. So I suspect, we have not implemented IoT yet, that's what our next plan is. Suspect this is going to be really huge problem for the IoT and other devices. We want to implement this. There will be a lot of duplicate roles, a lot of conflicting roles, and there will be overlapping roles will be there. That's kind of challenge which we will be facing with the IoT and other kind of network structures. Again, false positives, true positives. This chart shows that we're more or less on the left side. Most of them are correct. That's what it shows. Again, these are all performance parameters which we use for research. Make sure that what we do is actually working. So our future work is that average Joe can configure and monitor IoT devices. That's our next step. Also, we are doing voice recognition, so people can actually speak as we go through. We just speak, and then that will be converted like Alexa. So that will be downloaded. So we have to do more analysis of the NSF logs. So the logs coming back from Cisco firewalls, we're going to do a bit more analysis. We may have to use some special NLP techniques or special machine learning techniques to actually understand why we got rejected, so that we can change our NLP machine. That's what our future work is right now, what we are completing. So this work is about developing a reliable system, very important. We want to be a robust and reliable system using machine learning, that is NLP processing, to understand the human language. So convert the human language into security rules. Why? Because we want everyone, all citizens, participate in securing the cyber. That's the objective of this particular study. There are various kinds of enterprises, various kinds of people, various kinds of languages. They're all challenges, right? This is not a, okay, I don't talk anything. They're all backup slides of the questions we asked. So any other questions you want to ask me now before we conclude this talk? I think we have time, maybe plenty of time. We have another 5 minutes. Yes, please. Any kind of what?
Like if the average Joe just said disable the firewall, would there be like any kind of safety mechanism?
Yeah, so right now, we actually have a thorough processing of those input rules, okay? So obviously we're going to reject some of them if the user themselves trying to block you, trying to sabotage your system, okay? Yes, please. You want to ask a question? No.
I think we can use the microphone up here.
It's not working, right?
Oh yeah, battery's dead.
Yeah.
Who had a question?
There's no questions. Thank you very much.